Okay, grade 12, welcome to the last lesson of drawing a diagram. So let's look at this information that we are given. We are given the cos of 44 and they say this is equals to A. Remember, the first thing that we need to do is to analyze the given information. So I'm going to write my cos 44 degrees, which is equals to the value of A. Remember, if we bring the SOHCAHTOA, this will be cos its adjacent. I can say A is over 1, right? I can say A is over 1. So cos its adjacent, which is x, over hypotenuse, which is r. So now we know that the value of x is A, the value of r is y. We need to find the missing value. But now before we do that, let's look at where we're going to draw the diagram. So now we don't have much information for us to draw the diagram, but only the angle 44. What is that angle 44 telling you? It tells you that your diagram should be where? In first quadrant. Where is angle 44? It is between, that angle is between 90 and 0. 90 and 0, that's quadrant 1. I'm going to draw my triangle on quadrant 1. This is my triangle and I'm happy with that. Now I need to give my triangle some labels there, and what I'm going to do, I know that I'm given this angle as 41. So this angle is 44. I'm sorry, this is 44 degrees, and we know that r is the hypotenuse, which is 1, and we have x, which was given as A. What is y? Our opposite, unknown. We need to use what? Theorem of Pythagoras to find the value of y. So we can substitute it back on that equation. So we use the formula r squared is equals to x squared plus y squared. What is r? 1. And the value of x is A. So I'm going to substitute this as A, and we are looking for y. So if we solve this, is 1 minus A squared, which is equals to y squared. We need to square both sides so that we can find what is the value of y. When you square both sides, y will be plus or minus. You see, I always say plus or minus. Then that's when you can decide on the value of r, of y. Where is this? This is in quadrant y. How are the y? All of them are positive in quadrant 1. Therefore, the value of y is the root of 1 minus A squared. So when you have this information that you got when you use the theorem of Pythagoras, this tells you that you have all the sides and you can start answering the questions. Let's start with the sine 46. Let's start answering the sine of 46. So now, remember, we said that whatever angle that we are given, so what we're going to do, we need to make sure that the angle relates with what we have inside the bracket, inside our triangle. Let's go to this triangle. Let's write down everything that we know about that triangle so far. We know that this is 90 degrees. That's one thing we know. Then we know that if this is 44, remember the sum of angles in a triangle should end up to 180. So you need to ask yourself, what is that angle equal to? So you're going to say 180 minus 90 minus 44. The answer that you get will give you the size of that angle, which is 46. So can you see that the 46 is the one that they are looking for, which will change our opposite to hypotenuse. Remember, this is my opposite, this is my adjacent, just gonna use A, and this is my hypotenuse. So if I'm using the angle of 46, this opposite becomes my adjacent, this adjacent becomes my positive. Then let's try to answer the question. Okay, so I'm going to bring down my diagram here. This is my diagram. We have this as 90, this is 44 degrees, and this is 46. So now, for the fact that we are looking for that angle, we are using that angle, so this will be my adjacent, this will be my opposite, and this will be my hypotenuse. So let's try and find this. Let's see what we have. Let's do this. This will be the sine 46. It's equals to sine its opposite, which is this side, right? Opposite, remember this side is our x. Let's go back and check. We have this side as a, the value of that side is a, and then we're going to say this will be a over hypotenuse, which is 1. Therefore, we've successfully find the sine of 46 degrees. It's just a. Then we need to answer the next question. What do we have on the next question? Look at the next question. We have the tan of minus 764 degrees. We have the sine of what? We are looking for the tan of. So now, when I see something like this, I can see that I have what is this? A negative angle. You need to ask yourself, how can you work with negative angles? We are looking for, this is B, the tan of negative 764. And you know, when I have something like this, you know what I'm going to do? I'm going to say this is the same as the tan of, I'm going to take that negative 764. We add 360, because when you add 360, let's see what we get. So you can see that whatever that you get is still a negative angle. So we're going to say minus 764. We're going to add 360. This gives us negative 404. So on that negative 404, we need to add 360 again. We need to add 360 degrees again. Then look at what you get. You get minus 44. And remember, we have 44 degrees in that triangle, so we can work with that. We can write this as the tan of, inside the bracket, minus 4. Yeah? So now that you have something like this, what's next? This is a negative angle, and it is in quadrant 4. Remember, negative angle, it's in quadrant 4. How is tan in quadrant 4? Tan is negative. So since tan is negative, I can just change this and write it as negative, the tan of 44 degrees. That's easy, né? So we need to solve the tan of 44 degrees. Remember, we had x to be a. We calculated y to be the root of 1 minus a. So it's the root of 1 minus a squared, and then our hypotenuse is 1. So what I'm going to do, I need to find the tan. According to SOHCAHTOA, tan is adjacent over opposite. Let's go and check SOHCAHTOA. This is my tan. It's opposite all over adjacent, so it's y over x. So we're going to say this is negative inside the bracket. Opposite is the root of, this will be minus 1 minus a squared divided by a. And then now we close the bracket. So you can just multiply out the bracket with negative, which will give us negative the root of 1 minus a squared, and everything is divided by a. Then you've managed to answer this question. The most important thing for you to do is to make sure that you change that negative angle. Let's see what we have on the second. Question number 3. We need to find the sine of 89 degrees. Sine of 89. And remember, we are still using the same triangle, so we need to bring it down, and then we can just refer from this diagram. Let's bring the diagram down here. This is what we have. Then on the diagram we have the angle of 44 and 46. I think everyone understand where we got this 46 degrees. We use sum of angles in a triangle, and the value of r was 1. We calculated y to be the root of 1 minus a squared using theorem of Pythagoras, and from the question we already know that x is a. So now let's use this diagram. We're going to use the diagram to do what? We're going to use the diagram to answer the question that says find the sine of 89 degrees. So this is the sine of 89 degrees. Remember, what you need to do, you need to check how can we make 89 to be related to those angles that we have inside a triangle. Look at this. We know that if I say 89, I minus 44. What is your answer? So 89 we minus 44. This gives us 45. So this tells us that we can change this and write it as the sine of 45. I'm happy with 45 because this is a special angle. I'm happy with that. So this is a special angle. Then I'm going to say 45. Then we're going to add 44. So if you say 45 plus 44, what is that equals to? The angle of 89. So what's next? This is the double angle for sine. So this will be the sine of A plus B. It's equals to the sine A cos B. Therefore the sine remains the same. We're going to add the sine A the cos A sine B, the cos A times the sine B. So we know what is A, we know that. We know what is A, we know what is angle B. So we just have to substitute. Where there's A, we put 45. Where there's B, you substitute 44. It's easy enough. So this tells us that this question, we can write this guy as the sine A, which is 45 degrees, multiplied by the cos B, which is 44 degrees, and then we're going to add the cos of A. What is A? 45 degrees. We're going to multiply this by the sine B, which is 44. So now the 45 it's a special angle. We're going to use the calculator to use that 45 to find the 45. But now look at this. This one, the cos 44, to get that we're going to refer to the diagram, and to find the sine 45 we're going to refer to the diagram. So let's start with the sine 45. And remember they said without using a calculator. So on your calculator, when you work this thing, when you pass that, when you say sine 45, you're going to get that your sine 45, it's equals to something like root 2 over 2. This is how they know that you used a calculator. So if you give them that, just know that they're going to know that you used a calculator. So you need to rationalize that. So I know most of the time at school, maybe your teachers, they just say, you know what you need to do? Just say this is 1 over root 2. Now let me explain where is the 1 over root 2 coming from. We take whatever that, if the number inside the square root is the same, if the number inside the square root is the same as what you got, is the same as your denominator, you rationalize the numerator. It's like saying the top part multiplied by root 2, the bottom part multiplied by root 2. Remember, this is just 1 because root 2 and root 2 cancels. So what do you get when you multiply the top? Remember, we row multiply, we row multiply. So this will be, the top part is just 2, then what is the bottom part equals to? This will give us over 2 root 2. So can you see that the 2 cancels on top, we left with 1, and our denominator is just root 2. So when you find that your special angle, when you put it inside the calculator, you get root 2 over 2. The number inside the square root is the same as the number on your denominator. You just have to rationalize the numerator. So when you rationalize the numerator, this is what you get. So now we need the cos 44. How can we get that? We need to refer to the diagram. Look at the diagram. We know cos is adjacent all over hypotenuse, which will give us a over 1. So I'm just going to substitute this as a over 1. Then plus the cos 45. Punch that on the calculator, still gets off, we get root 2 over 2. I'm going to substitute that as 1 over the root 2. Then let's close the bracket. The sine 44, we use the bracket which is opposite. This will be the root of opposite 1 minus a squared all over hypotenuse. This is 1. What's next? Simplify this. So we row multiply that 1 times a is just a over root 2. We're going to add this with the root of 1 minus a squared. No stories, just marks. This will be over the root of 2. So what happens on the denominators? The denominators are the same. We can just write this thing as 1 fraction. So this will be root 2 on bottom. The top part is a that we need to add to the root of 1 minus a squared. And then you've managed to solve that question, where they want you to find the sine of 89. What about the cos 88? How can we find the cos of 88? We need to use the same diagram. So what I'm going to do, I need to bring my diagram down here, because this diagram, we're going to use it for all the questions that we're going to work on. So on this diagram, I have my angle here as 44, and this is my 46, 90, y that is equal to the root of 1 minus a squared, x that is equal to a, and we have r that was equals to 1. Let's answer this. What is the cos 88 equals to? I need you to pause this. Make sure you try it. Let's see if we get the same answer. So now, when I solve this, first thing first, I can see that 44 degrees will be half of what? Half of 88 degrees. So I'm going to write this as the cos 2 inside the bracket 44 degrees. Right. So this is a double angle for what? This is a double angle for cos. So we need to use the identities. So which identities we can use? We can use any identities. So I prefer that we use for sine. Yeah, I think it's best if we use the identity for sine. So now, the identity that we're going to use on this one, we can write this as 1 minus 2 the sine squared of what? You need to be very careful. The sine squared of alpha. So let's talk about this now. What I'm saying is that this, if I have the cos 2 alpha, this alpha is equal to 1 minus 2 the sine squared alpha. So let's substitute what we have from this equation. Let's substitute what we have. So the first thing, I see that I have the cos of 2 alpha. So where there's alpha, we need to substitute. Remember, we said we'll change the 88 into 2 cos 44. I hope you're still with me on that. Né? I hope everyone is still with me on that. So now, when I have this, this will be 1 minus 2 inside the bracket. Okay, I think we are missing something. Let us stop here and let us go back. Let's go back. Let's go back on choosing the identity now. We're just gonna go back and fix the identity part. Okay, so let's look at what we worked on previously now. We worked on cos 44 and we worked on sine 44. So we know what is sine 44. We know what is cos 44. So we can choose any identity that has to do with sine 44, and we can choose any identity that has to do with cos 44. So maybe let's say we choose cos 44. Which identity are we going to use? 2 cos squared. Let's write it down. I hope no one will be confused on this, okay? So what we're going to do is that we're going to say this will be equals to the cos of 2 alpha. This will be equals to 1 minus 2 the sine squared alpha. Right. Or this is equals to 2 the cos squared alpha minus 1. So now I can choose any of these two. So I'm going to go with the second one and say that when I go with the second one, this will be the cos of 88 degrees. I'm sorry, it's equals to the cos. We know that we can write this as 2 inside the bracket 44 degrees. Okay, so far so good. So now the cos of 2 inside the bracket 44 degrees, we can write this guy as 2 the cos squared of 44 degrees minus 1. But we know what is the cos 44 equals to now. If we can go back to the previous question that we solved, if you still remember, we have the cos of 44. We know that cos 44 is just a over a. If you still remember, the cos 44 is just a over 1. So now this will give us to substitute this as a over 1. But remember, this is squared. We minus 1. Therefore, this will be 2a squared minus 1. This should be easy. Né? This should be easy. So almost we wanted to complicate things on that one. Eh? But when it's like this, it's easy. We can leave it like that. Let's answer the last question of the lesson. So the last one, it says, look for sine 22. So I'm going to write down the sine 22. Remember the method that we were using when we had theta over 2. That's what we're going to work on. Most important, bring down your diagram, because this is what we're going to do. Y was equal to the root of 1 minus a squared. We had x to be a, we had r to be 1, and this was 44 degrees. This was 46. Okay, so from this diagram, we are looking for the sine of 22 degrees. And we know that if I write the cos 2 alpha, this will be equals to, we can say this is equals to 1 minus, because we are looking for sine, we're going to use the identity that has only sine. So this will be 2 the sine squared alpha. So this is what we have so far. So now remember, this can be written as the cos of 2 inside the bracket 22 degrees. So we know that where there's alpha, we just substitute 22 degrees. This is equals to 1 minus 2 the sine squared of what? The sine squared of 22 degrees. When we have this, the next thing that we can do, we just have to solve for sine 22. Simple. So now this is cos. If we multiply out the bracket here, this will give us cos 44. Equate this to 1 minus 2 the sine squared of 22 degrees. What else do we have? So the cos 44 degrees, we know that the cos 44 degrees, we know what is that equals to. So the cos 44 degrees from this question, we said it's a over 1, which is just a. I'm just going to substitute that as a. So this will give me a, it's equals to 1 minus 2 the sine squared of 22 degrees. What's next? To solve for a. So I'm going to bring the 2 sine squared 22 this side to be positive, so that everything can be easy for us. Then on the other side we're left with 1 that we need to add a. Oh, the a will go to the other side to be negative, so we're going to subtract a that side. So this will be minus a. Okay, so I think everything is good so far. We can just divide both sides. Né? We can divide both sides by 2. Make sure that this side you divide everything by 2. Therefore, what is the sine squared 22 degrees equals to? It's 1 minus a over 2. But remember, if I have the sine squared 22, the aim now is to remove what? The aim is to remove the square. How can we remove the square? We can just square both sides. So the sine 22 degrees is equals to plus or minus. You know, I always say plus or minus. This will be 1 minus a over 2. So when it's in this form, we can say therefore the sine 22 degrees will be equal to, we need to decide where is 22 degrees. This is in quadrant 1. How is sine? Sine is positive, so the final answer is just 1 minus a over 2. So that should give you the final answer of 1 minus a over 2, the root of 1 minus a over 2. And that's it for this lesson. So if you liked the lesson, please make sure that you subscribe so you don't miss the next